Welcome to our ZeWIF developer meeting. This is, I think, the fourth one that we've had since we started this project. We've made some good progress, but we're kind of reaching the point where we need to start diving into some details and um, closing some things up. Um, why don't we start with you, Wolf, with a project update on what you've been working on, and then we'll have everybody bring up their topics and issues. Thank you.
Yeah, so this will probably take a few minutes. Feel free to jump in with questions anytime. I'm Wolf McNally, the lead researcher for Blockchain Commons, and I've been the point person for creating the tool stack for ZeWIF, the Zcash wallet interchange format. Since the last meeting, the main meeting where we actually collaboratively created, kind of defined the structures that would be the ZeWIF in-memory abstractions. I've been going over those and basically adding instrumentation to them so they can translate themselves to and from the Gordian envelope format, which will be the actual ZeWIF binary format. I think I've made some very uh, useful and interesting progress. I think it's taking us, 90% of the way there towards where we need to go at this point. And obviously, I think that this is actually the best time now for the community to begin collaborating as a whole to actually bring these together into a tool set that the whole entire Zcash community can use. So I'm going to show you some of the progress I've been doing. And Chris, you had a question for me on Signal, which I'll get to when I look at some of the code here. But I want to let me start by uh, sharing my screen here. All right. Zoom clutter off my screen here. Okay. All right. So the ZeWIF crate, which again is part of a stack of currently 3 crates that will become more, and 4 crates, including the ZMigrate. So the ZeWIF is the core, and it's got very few dependencies, but does depend on our Gordian envelope crate, VC envelope. ZMigrate is the actual command line tool. And I have in the ZMigrate directory, actually, I'm going to recreate some of these. So I'm going to actually delete these right now because I'm going to recreate them in a minute for you. All right, so I'm going to start with a demo wallet DAT. This is a Zcash wallet, one of the fixtures that is in the actual repository. I think this is from the Golden branch. And I'm just going to show you a few things about this, about the ZMigrate tool as it stands right now, and what's complete about it, what's not. Later on today, I'll be releasing a much more complete README and things like that. But for now, fighting with several windows here that you can't see. Okay. All right. So let's just run ZMigrate help. This is kind of show directionally where I'm headed. We're using clap to parse command line arguments here. Generally speaking, there's a required from switch, which is the input type that you're giving it. In this case, the 2 possible values are Zcash and Zingo. Zingo's not currently implemented at the highest level here. It still has only partial implementation at the lower level, and so we're not going to dwell on that. Zcash is what we're going to mostly focus on, and of course, we're ingesting Zcash. We're not going to be planning on writing out Zcash because of its deprecation. And let's discuss this with Chris before, but the idea is that we're not going to try to use heuristics to detect the wallet format. We're going to actually have that supply on the command line along with the format. The 2 format currently is the output format, and the default is ZeWIF itself, which is the Gordian envelope-based binary format. UR is a text armored format for UR stands for Uniform Resource. It's a blockchain commons spec. I'll show you. You'll see that more in a moment. Format is basically human readable formatted output in what's called envelope notation, and dump is the actual debug dump that you saw last time. So that functionality is still there if you want a Rust debug dump of the actual ZeWIF structure. Because remember, there's two sets of structures. There's the structures we're reading directly from the source file, which is the Zcash D format, and then there's the ZeWIF format, which then those are then converted to, and that's the intermediate format in memory, which then will be supporting writing out to various formats. And currently now, the main thing I'm showing you now is how we're going to be writing out to the ZeWIF format. There's also two switches for compress and encrypt, because we've talked about it's particularly the desire to encrypt the envelope, and all the tooling in there is to do that, but it will panic if you try to encrypt it right now, because that's a to-do. But compress does work, and I'll show you that in a moment. But all the armature is there for that. So I'm going to actually pull up some command lines here. Let me go to my demo directory. Okay, so this is the demo. We're going to go into the demo directory here. This is the first command line I'm going to run. Zmigrate from Zcash D from the demo wallet to demo wallet.zwif. And this is basically just converts to ZWIF silently. I do ls long human readable. Then you see that the original file is 296K. The output file ZWIF is 93K. The reason for the difference is the DAT file is a Berkeley DB file. And so it probably has a lot of extra space in it, as database files are wont to do. But it's 93K is still significant. If we wanted to, we could actually rerun that as compressed. So we're now going to do the exact same thing. We're going to have a different output file format and compressed. Now, Gordian envelope essentially, supports compression and encryption of various kinds out of the box. It uses the deflate algorithm, and I'll show you a little more about the structure of that as we proceed. But we're basically going to do the same thing here. This is this is an equally compatible ZWIF file. List that, then you can see it's about half of what the original one was. Part of why we get such a good ratio of savings here is that there's a lot of text strings in the ZWIF format as it stands, and you'll see why I chose that in a little bit. We didn't have to do it that way, but it's actually easier to do everything as text strings. Then if we decide that size is an issue, go back and do another pass where we replace them with assigned integers called known values. We may decide not to do that at all. It may not be necessary in this case. So right now we're not at this moment round tripping the binary format, and I'll show you why that is in a moment here. But the next thing we're going to do is actually do another from Zcash D, but I'm a different output format to UR, same input file, different file. This is a text file, and I'll explain why I'm doing this temporary thing in a little bit. But this will probably stay as a possible output format, but it won't be very commonly used. So if I actually go and if I open that up, you'll see it's basically a wall of text, and this is basically about every 2 characters is a byte here. And the idea is that you see it's marked with human readable UR envelope at the beginning. That means this is a Gordian envelope. And all of our tools right now, all of our command line tools currently ingest this format. We will be also making it so that the ZeWIF tool actually ingests the pure binary. I will probably also update our command line tool to ingest pure binary, which it doesn't currently do. It only inputs and outputs the UR format. But
one of the key things of the UR format, it's broadly used in the Bitcoin community for air-gapped communication. It's optimized for QRs and has some other features. I don't know that the Zcash community needs that at this point, but it is an option.
It's there, and the reason I actually prioritized adding it, even though it's just one line of code, was basically so that I can show you the next thing, which is that Actually, I'm going to also do this as compressed as well. So again, because we're going to see some differences between them here. Oops. Okay. So I just actually created the compressed version of that as well. Here, so it's basically the same idea. It's shorter, but we don't need to look at it or see what your URL looks like. Okay, now I'm going to actually use our envelope command line tool. Our envelope command line tool is another Rust tool. Also uses clap. It's basically our kind of our kind of Swiss Army knife for Gordian envelope. And I'm going to tell it to format that, format its input, which is going to be taken from standard input, the file we just created, and then output it to just a human readable text form text file. And right there. So now we're getting into human readable territory. So this is you might look superficially like the debug dump we did, but this is not JSON. This is not CBOR object notation, or this is called envelope notation. And if you see my presentations on envelope, you'll understand it. But every envelope has a subject. In this case, it's a random identifier of the subject, and then a series of assertions. In this case, is a ZeWIF is an assertion. This is subject, predicate, object, predicate, object, predicate, object, all the way down. So if I actually collapse some of these, in fact, I'll collapse all of them. You see that the most of the assertions in a ZeWIF are transactions. If I go down to the bottom, you'll see that there's also some number of wallets. Transactions are identified by the 32-byte transaction ID. Wallets are identified as an index. The index itself is the subject of another envelope because it's all nested, it's all recursive. So wallet 0 is a ZeWIF wallet. And these assertions are used, if any of you are familiar with CBOR and CBOR tags, if you use these kinds of assertions in a Gordian envelope, you don't need CBOR tags. You don't need to identify everything using a CBOR tag because you have these assertions. And so you know that this thing, the subject, is a ZeWIF wallet. And so therefore, all the assertions on it are going to conform with what the ZeWIF wallet class writes out. In this case, it's 3 accounts. We can drill down into one of those. So the account 0 is an account. It's got a series of addresses in it, as well as a name, a set of relevant transactions. Actually, let's find an account that actually has, there we go. There's a set of relevant transactions there. This is actually a CBOR array, which is why it doesn't stack. It's actually being output. It's just a CBOR object. So again, you can mix and match. This is, Gordian envelope is a CBOR based format. And so you can have CBOR anywhere as subjects, as assertions, as predicates, as objects. The address itself, in this case, it is an address. This is the actual address that was parsed from the original envelope. This says this is a unified address, and it has a CBOR map as the component address. And other fields you probably recognize. The seed material, for instance, here is the actual subject is the BIP39 string. This has 2 is assertions on it. And you'll see that sometimes in the envelope, you'll see more than one is assertion. This is when basically types have a kind of an inheritance or subtype relationship, where this object is basically can be parsed by either of these subjects. In fact, often you'll see we'll parse one of them like seed material, and we'll hand that off to another type like BIP39 mnemonic to basically get its other things, its language, its bytes. So this actually gets me back to Chris in Signal asked a minute ago about the spending key type and wondered whether we were actually repeatedly parsing out the spending key here, because you see it says sapling spending key try from envelope. And by the way, cloning is an O of 1 operation here because we're actually using reference counting internally. So you can clone an envelope basically for no cost. And in this case, if it's a spending key itself is an enumerated type, and there's 2 possibilities. It's either a sapling spending key or it's a raw blob of data. And so we're deciding which of those to use. But it looks like we're doing two try-froms here. And so the fallback is but this is basically if I go actually into sapling spending key, try from, and then look at the actual try from envelope for that, all it's doing is saying calling check type envelope for sapling spending key. And that's basically what you saw here. What you saw here, well, with the output, where you saw those two isotypes, where you'll see two isotypes on this type as well. And so all it's doing is just in memory checking one and then checking the other, checking the super type, and then passing off to the subclass to check the subtype. It's just a string comparison. If it fails, it goes back and then uses the fallback of checking for the blob. So it's really not actually parsing out anything other than just doing two string comparisons there. And if that doesn't answer your question, let me know, Chris. So let's see. Right, so back to our formatted output here. So yeah, so you'll see a number of places where there are two is assertions. That's completely intentional. So we'll go back to the top here. Let's just completely expand a transaction here and quickly kind of scroll through it. You see this is a transaction. There's the block hash. There's a field that for transactions, which is the raw transaction. In the case of Zcash there is no raw transaction for us to parse out of the file. So we basically afford either. And when things are not present in envelope, then you generally won't see an assertion for them. We could add an assertion with null. Null is supported by envelope, but generally speaking, our convention is that if it's not there, we don't have an assertion at all. We just detect there's no assertion for that. There's a set of inputs where this is a transaction in, this is a transaction out, and status, timestamp, same thing. As we go down here, you'll see different kinds of, well, in this case, there's another transaction. Let's see, I'm trying to do an orchard transaction here. Search for orchard.
So I noticed that this text format is lossy. It's presumably
yes,
only intended for debugging.
That's correct. It's not a round trip format.
It's kind of, yeah. We need to be very clear in the documentation that that's the case, and that you shouldn't actually rely on.
Most people will never see this. This
is
strictly for development. The actual ZeWIF format that you saw written out here, which is, if I actually open up the ZeWIF file, it's going to warn me it's text. I'm going to say go to the text editor here. This has everything in it. As you can see, it's got embedded strings in it and all that. But this is the true binary format, and that identifies itself as ZeWIF right up top and all that. But the point being that that's not lossy. This is lossy, and this is just for debugging purposes.
Yeah, I mean, I don't see there as being a whole lot of risk, because when there's a bunch of things that just say, bytes 32, then, you can't get anything useful from that. So
that's also part of the intent is in many cases in this is basically just a CBOR byte string, and that's how we represent CBOR byte strings. And we often know that envelopes will have sensitive information in them. So rather than
that's a fair point. Yeah.
Wolf, can you scroll down just slightly?
Yeah. I'm just thinking that also that it's less useful for debugging.
I'm concerned. I'm concerned about speaking of debugging. Given that you have 4 orchard actions with the same note commitment tree position, it looks like there's something lossy in the conversion from the source data into the orchard action type, because you can't have 2 actions with the same note commitment tree position.
That could easily be a bug.
Yeah, that's a bug.
And that's the kind of thing that you're going to notice here. And that obviously, because that, for example, note commitment tree position is just a symbol, essentially, because we're using symbols everywhere. You can actually see here, and you can actually find where it's being used everywhere, and you can easily debug that. So it's just, I've designed the actual, for example, if we look at the orchard action description here, and we go to its envelope, you see here that what we're doing is we're creating an envelope new. The subject is the index of this particular orchard action description, which you saw reflected here. There's the index. And then we're adding a number of assertions to it. Type is a special assertion. This is the is assertion. And by the way, when you read envelope notation, you'll notice that some of these predicates have a single quotes around them, some of them have double quotes around them. The difference is that the single quotes are called known values. They are actually internally, they're integers. There's a mapping in our tool stack from those integers to we have a registry of those. Anybody can register new known values. They're meant for basically ontological concept. You can think of them as like CBOR tags with no content, except they're not really they're a singular CBOR tag we registered just for this purpose that has a 64-bit integer up to 64-bit integer as its content, and we call that known values. But that's one way. That's one thing you can use for predicates, and is our standard known value for typing. For all these other ones that have double quotes around them, these are CBOR UTF-8 strings that are just assigned directly in the code. Obviously, it's on you to make sure that we are consistent with them. I'm not assigning them separate symbols at this point. Obviously we could take a pass to the code and make sure we're not repeating ourselves. We could even convert these to known values if we decide that we want to do that. But I just want to make sure you understand the distinction between the single quoted strings and the double quoted strings. So
I noticed that the ZK proofs are absent because they're byte 0. Is that because they were absent in the original database, do you know?
Yeah,
or
well,
is there a design decision to not include them?
If it was in the original database, it should be here. If it's just a 0-byte length, then that could be a bug.
I can't remember the schema, whether it was optional or not in the database.
So the thing to check there in this case would be the ZeWIF Zcash D crate has the migrate to ZeWIF function, which is basically what converts all the ZeWIF, the Zcash D in-memory abstractions to the ZeWIF abstractions. And that would be where this is assigned. Obviously, if there's a field here for it, if it wasn't moved over, then that's a bug. And again, I'm not claiming anything here is complete. So mostly the purpose of this meeting is to kind of familiarize you with the architecture that we're putting in place, so that we can all go in here and bring together loose ends, polish all the pieces, identify anything that's truly missing, add it, and then actually be able to completely round trip wallets, convert wallets from formats, and so on. Obviously there's still a fair amount of work to do, but I think this is an important moment in the development now, where
I mean, for some purposes, you don't need the proofs because they're assumed to have already been checked.
And if that's the case, generally, I think we spoke about this in the last meeting, that we would, typically just omit the actual, if, like, for example, if it was option none, we would just tend to omit the assertion entirely. And then you'll see, for example, there's certain things here like add optional assertion, and this basically checks the value of memo, and because this is an option data here, add optional assertion will not add this assertion if this is option none, and will add it if it's option some. So
I have a question here about just in general versioning. So let's take the the orchard bundle type, which is which contains the orchard actions.
Right. This is actually part of the ZeWIF Zcash D abstraction.
Yeah.
There, but yeah.
So the orchard bundle type, in terms of the ZeWIF Zcash D abstraction, it's maybe not as relevant, but in terms of the ZeWIF type, the contents of that bundle is relevant. There will be additional fields in the bundle as of NU7. And so, there are other parts of, for example, the transaction format that will change. To what degree? So
and they have changed in the past. Carry on.
To what degree will I wonder how much we should be storing the sort of the decomposition of some of these types that have a specified encoding, like transactions. There are certainly pieces of transaction information that we need for wallet migration. For example, information about sent outputs that may not be recoverable from the raw transaction data, given the keys that are present. But I think that there are probably a number of cases where uh, we should just essentially anything that has a protocol defined encoding, we should probably just be storing bytes in order to make this format more future proof.
That makes perfect sense to me. And obviously, what I was going from was the documentation I was given where everything was parsed out. And for example, if in this case we have the implement parse for Orchard Bundle, where we're actually being given a parser with a buffer of data in it, and then we're calling the parse macro repeatedly for flags,
Yeah.
balance, anchor, proof, and so on.
Yeah.
And so we're parsing out those individual fields and then assigning them to the individual fields of the structure. If that doesn't make sense, because this is a well-defined structure and it's not necessary to have these fields parsed out for migration purposes, then you're right. This should all be replaced with a single just, hey, dump this buffer into a blob here.
I agree with Chris. I think
we're
that's a
done.
better approach because it's
And-
not really the responsibility of this format to do that parsing, I think.
Absolutely. And then there's a number of cases where, I've realized that that's not necessary. In this case, I didn't. So I just did it kind of by the book. But as you go through the code and identify these parts, then please just, rip out this stuff, replace it with what needs to be there and do a PR. And I will happily accept it. So
There was also a comment in the chat about registering CBOR tags, and we should probably do a little bit of talking about that. In almost all cases, the ISUP is probably the best answer for things. The question is for longer term migration, when you have objects that other protocols, other things might use, reuse, etc., there can be a benefit to registering a CBOR tag. I don't know of any specific cases for that. There could be some things that are, um, uh, where having a CBOR tag in the future will be very useful to you. But that's one of the things that we should have a larger discussion about.
right. Well,
Those
obviously, if you look at our if you look at our where is it here?
just a question there.
Yeah, go ahead.
Is there any name spacing for CBOR tags? Because it seems like it might be useful to have at least a namespace like Zcash colon or something like that registered, and then within the that could prevent collisions outside of the Zcash ecosystem that might otherwise occur. I guess what I'm asking is I don't know what the registration domain is. Like what tags need to be registered, or what does the registration get you?
Right, because we've been using Gordian envelope, and because Gordian envelope is it's a layer of abstraction above CBOR, so it internally uses CBOR tags. We actually registered with IANA tag number 200, which represents Gordian envelope, and tag 201, which represents dCBOR. And we actually had to go through the IANA process of having our proposals reviewed by IANA experts to determine that our proposals were stable and of a reasonable quality. And it's not the full RFC process, but it is still scrutiny by outside experts to get those tags registered. Above a certain level, above like 32,767, it's first come, first serve. We've also registered a number of those tags for various purposes, including tag 40,000, which is we registered for known values. So the content of that is just a tagged integer, which is tagged 40,000 and then whatever the tag. So it's 2 bytes of overhead basically.
To express it another way is that if you're for the larger tags, i.e. in size, they're relatively easy to get, first come, first serve from IANA. But our lesson from the Bitcoin community is that sometimes, so specifically in the Bitcoin community, they have something called a partially signed Bitcoin transaction. There were some individual things that were used without the envelope structure. those things we went ahead and registered IANA tags for, because they were being used outside of envelope, in particular for QRs. Um, the but if you're, you know, completely within kind of the envelope approach to things, you don't necessarily need to register all of those. So I think
Exactly.
it's all about where the lines are of reuse of these.
Got it.
Right.
Okay,
So
so the top, essentially you want tags registered for top level types, but
when
below
you
that.
want to, when you're not yet, well, actually, you don't even need that with Gordian envelope. That's the whole point, because
Oh,
Gordian
okay.
envelope has this is abstraction, so there's no new tags at all in this entire ZWIF format. That does not say you couldn't have them. I could have them for everything, in which case I'd have to actually go through the process of registering dozens and dozens of tags. But because I just have this identifier, and in fact, you know, we have actually you know, a few known values that we use as objects here for ISA, and then a well-known object. So if you look in our stack here, BSIN components in the tags registry.rs, you'll actually see this is all the CBOR tags we've registered. Here's 40,000 for known value. You know, we've registered other tags that we're using. Some of them were actually too low. We didn't go through the IANA process, so we actually reassigned them to a higher level, 40,300 here. So you'll see, but you know, we have registered a number of tags for various reasons. If you look at tag 200, there's tag envelope, tag 201 leaf, which is basically has to be DCBOR, our deterministic flavor of CBOR. And these are used, these are basically the foundation upon which Gordian envelope is built. So if you actually parse a Gordian envelope as pure CBOR, you'll see a lot of these tags. And you'll see that in our internet draft, IETF internet draft, you'll see how these are used. But generally speaking, at the level of abstraction of Gordian envelope, that becomes unnecessary. If you and then elsewhere in our code, there we also have a registry of our known values, and we also have a paper where we actually publish the registry of our known values. And anybody can register a known value. You don't even have to go through the IANA to do that. Now the question is that even necessary for what we're doing here? And at least at this point, I've determined the answer is no. This is the self-identifying structure at the very top. If you parse it as an envelope, it has a random identifier, and then the very next thing is a ZeWIF. And so if this assertion is present, you know it's a ZeWIF. And that brings me to another thing here that I want to show you, which is that if I look at the compressed, let's see here. Let me actually.
Yeah, I mean, I'm not worried about using text tags. It's small enough anyway, and
yeah.
With compression, it's
right. So I'm actually.
I think you're barely there's barely any cost to using the text strings. I was going to say on the issue of versioning. So some of the structures in the protocol are versioned with the transaction format. So I'm thinking, for example, of spend and output description v4 and spend and output description v5 for sapling. Is that reflected in the database, or because ideally you don't want that to be just context dependent on the version of the surrounding transaction, because it is actually a different format that you have to parse differently.
Right. So in the actual, because of the docs I was handed for Zcash D, in some cases, you know, how a structure was parsed was dependent upon an embedded version number. In which case, you know, I replicated that logic in the ZeWIF Zcash D.
All right. Yeah, that's what I wanted to be.
Yep. And of course, if that isn't right in particular cases or whatever, then, you know, please feel free to go in and correct that so that it actually makes more sense.
All right. So
as long as go on.
I was going to say one thing, you know, this is where we really need your help on. So in some cases, we want to parse those and divide them up. But in some cases where things are going to be changing regularly, we may not want to, and allow for the higher level of the APIs, out of the wallet, to do the parsing.
Yeah.
And the specific example of that was in the Bitcoin community was the PSBT is constantly evolving. They're constantly adding things. So parsing a PSBT turned out not to be a good idea because there were constantly things being added to it. So, we basically, punt and say, you can put all the value there, but then it's the responsibility of the wallet to do the parsing. We don't know where those lines are for Zcash. Like, where is it
Yeah.
that it's really useful to
I'm
parse
drawing a
but
bunch of
not?
those lines as
Okay,
we
cool.
speak.
Excellent, excellent,
because
Chris.
in the migration process, I have to. So just expect a flurry of PRs.
That's great. Yeah, absolutely.
It's not,
And
in
I
our
don't mind
case,
throwing,
it's
I don't mind throwing away my work. I was just making sure that I was parsing everything and not missing anything. And then
yeah.
recognizing that this conversation was going to happen at some point.
Yeah, in our case, it's not that these structures change frequently. I mean, PCGTs might change frequently for the same reason that PSVTs do. But the transaction format itself changes once in a blue moon because people complain at us whenever we change the transaction format. But yes, it's more that it isn't really the responsibility of this layer to parse that because the wallets will all have parsing code themselves.
Absolutely. Yeah, it makes perfect sense. So I wanted to point out that because obviously we've talked about, compression, which is a nice thing to have, but probably not necessary, but encryption of ZeWIF files is very important. And it's basically, a very easy thing to do using Gordian envelope. I want to show you because I have the compression implemented. In fact, I just, again, told my envelope tool to format the compressed UR into into another text file here. Let's look at that. That would be compressed format. And notice it's also an envelope. It's got the same ID as the previous one. Actually, it's actually a different ID because it's been processed. I actually should copy it with the same ID. That's not that is a bug. So they should have the same ID because they're basically the same wallet. It's got the same is assertion, but notice that there's only one other assertion on it, which is content, and then this all caps compressed basically is a Gordian envelope that is just a deflate compressed. It's been serialized to CBOR and then deflate compressed. And its digest has been preserved, so the whole digest of the tree is preserved. So you can actually compress the Gordian envelope and its top level digest doesn't change. Now what we've done here, because you notice that here there is no content assertion here, where we're actually replacing these with a content assertion. So this doesn't have the exact same digest tree, but it is identifiable and will be identifiable as the same identifier. And if this were actually encrypted, then you would see this. And I'll be supporting that shortly. I've already got the armature in place to do that. But and you can also compress and then encrypt. Obviously, it doesn't make sense to encrypt then compress because encrypted data is incompressible. But the code supports that. In fact, let me show that to you. This is the armature I'm using for reading in and writing out Gordian envelopes in various formats. It's called ZeWIF envelope. It parses out the ID. It holds an envelope. So you just initialize it with the envelope, and the first thing it does is it checks to see is this a ZeWIF, and if not, it throws an error, and then extracts the subject of the ID, which is the identifier.
Quick question there. In the event of that we want to version the ZeWIF format, would it does it make sense for the type of the envelope to just be, ZeWIF, ZeWIF2, etc., or is there a separate approach to versioning the overall format?
I would say that it depends, because if you're going to introduce a new version of the envelope that is you need like an entirely different parsing structure for, then it makes sense to put version numbers at the highest level. If on the other hand you're going to slowly evolve different parts of the envelope of the ZeWIF format, just like you're doing with doing new release versions of Zcash, where you're leaving some things the same and changing others, then you might want to version those structures internally. And of course, any envelope can support in fact, we already have a known value for version, so we can actually have a version is 2, 3, whatever at any level. I'm not currently using anything like that, but we can do that easily. Currently, mostly
also to be clear, most people don't click on the fact that you can have multiple predicates. So you can have there are lots of ways of annotating with predicates other different types of things about a particular object. So you,
Right. I mean, that's the thing. In this case, the actual, if you look at any of these, I mean, again, this is subject, predicate, object, subject, uh, predicate, oops, didn't mean to move text there. So it's all the same ideas, one subject and then predicate object pairs. So this itself is a completely extractable envelope where the subject is 0 and then predicate object, predicate object, predicate object. So Gordian envelope is completely recursive in that way. Even this can be a complex object. A predicate can be a complex object. And it's just a very kind of uniform tree structure all the way down. Now, the ways you use it, generally speaking, you won't have unless you want to do various kinds of, and we give use cases for this in our other materials of why you might want to make this a complex object. Most of the time, you don't. It'll be either a known value or a string, um, and for certain simple things like arrays of just transaction IDs, I actually serialize that as a CBOR array. Whereas other things like the complex, assertion structures, if they are ordered like this, I actually use an index as the subject. Why? Because Gordian envelope does not preserve the order of assertions. They're actually serialized lexicographically by their CBOR serialization, and that's important because actually by their digest, because that basically makes the actual order of the serialization deterministic, and that's very important overall for Gordian envelope is to keep everything deterministic. Let me quickly show you this other part I was going to show you. If I look at the so if you compress something, then you basically using this armature, then you get the actual so once you actually have this in the ZeWIF envelope, say you just read in a raw envelope, then you hand it off to ZeWIF envelope, and you'll see this in the command line tool and the ZMigrate tool. I'm using this armature now. The first thing it does is check the type. Once it has that, then you can query it for the digest, get back the envelope, see if the content is obscured. In Gordian envelope, obscured means either compressed or encrypted. Or elided. Elided basically means the data is not there at all. It's just the digest is left. So in this case, we're supporting compression and encryption. But this basically gets back to the obscured content. You can also say, is it obscured? Is it compressed? Is it encrypted? And of course, a bunch of other,
so Wolf, I mean,
yes.
So, can you give an example of, let's say, with transaction, where if they needed to say, this is, version 5 or some text, because they know something's going to be evolving and it's not self-identifying as what the version is. Is that how would you do that?
I'd probably just add a version, I32 or U size or whatever here, and then serialize that out. And in fact, I think there are cases where I think, let's see, there's, with branch ID, which is an enumerated type. And actually, for example, a branch ID, which is basically a version number. I have, this is obviously try from U32. This is actually the binary format for parsing it from the binary format that turns basically its encoded ID into the a Rust runtime ID, and goes the other way as well. But I also have, let's see, then this is the parser for the binary level. I also have, I have string conversion routines because I'm using strings to make the, rather than encode the binary, I'm making it more human readable in the ZeWIF format. And to do that, I basically I'm parsing to and from strings. And then I basically also let these be parsed to and from direct CBOR to actually CBOR string values. And then I'm actually testing round trips here. So if I actually, let's see where I'm using this.
This is an interesting example because this is one of the places where here we probably should not just use strings because the explicit those U32s are semantically relevant, and so those we should be storing more directly. But that being said, this probably, since this is actually embedded in a transaction, if we go the route of just storing the encoded transaction format, then it won't matter, because
Agreed.
Right.
Yeah.
So that's fine too. I mean, in fact, it looks like I'm actually not serializing it anywhere, at least not in this envelope. But my point is, this is a way that you can do a kind of semantic versioning if you want to. Ultimately, as long as you have the two-way mapping between your binary pure binary format and strings, it's But if you did have
Okay,
to
so
encode a branch ID,
just to clarify, the answer that I'm hearing here is that is just to basically just be explicit, just version the things as part of the data structure.
Yeah.
How does that work with respect to parsing? Because, if you need separate parsers for separate versions, doesn't that, or sure you define a wrapper type that has the version and the payload, and then uh, this is where I'm
yeah.
not
So
confident
if
about how the like there's a stack here of the envelope and CBOR and then the in-memory type.
Mhm.
And
I
yeah,
mean,
just
for things in the Zcash protocol that we put on the wire, they are generally always
yeah,
encoded
those
in
are
a context
intrinsically,
independent way.
yeah.
We were talking about this at Real World Crypto about how encodings should be context independent. But for things like keys, I think that's not always the case. There's a string, so the string representations of keys are independent, but the binary ones are not.
Right. So in many cases, in the documentation was given and the envelope and the Zcash D wallets, there was references to client version. Client version in this case, parses out to basically, a semantic version number. But generally speaking, this is never actually passed directly to ZeWIF at this point.
Well, that's the client version is independent of the protocol version that was in effect at the time any particular
Yeah, I mean, this is still useful metadata
yes
to carry over, but it's not something that it's not part of the it's I think you talked about this as sort of thing that would be an attachment.
Yes, absolutely.
Yeah.
And I could talk a little bit about that as well. But go ahead.
I have to drop in a few minutes because I need to go to another meeting. But okay, carry on.
Did you have any final questions or thoughts?
Not so far. I think I've been asking questions as I went along.
Okay. Yeah. So basically, yeah, there's a number of different ways to version things, either through inclusion or omission of assertions, by adding explicit version assertions, by serializing binary structures that internally carry their version that we expect that the destination client will just parse because their protocol. It's very flexible. There's nothing rigid about how I'm doing things here. And it just makes sense to select whichever one makes sense for the layer abstraction you're working at. At the actual kind of high level version of envelope, you can basically you'll expect to see subjects, predicates, and objects. Whether or not they internally include a version or whatever in a byte string, that's a separate issue. Whether or not they have a version thing, I wouldn't slavishly add it to everything if you never expect to migrate that version, if it's just stable and it's likely never to change, like a transaction output. But but if you then later on you decide that maybe you need to add a field to certain transaction outputs, you could either add that field and then detect that as being a version that needs that, or you could actually add an explicit version assertion there. So, that's it's again, we didn't feel like it makes sense to have to be strict or dogmatic about how versioning is done, but certainly it's open to however you want to do it. I think I've covered most of the points I wanted to. There's, like I say, if you actually look at the let me actually stop at the kind of the very top level here, which is the ZMigrate main. This is where we're defining the clap parser inputs, outputs, and of course, feel free to modify this if you add things to it. Right now, there's not a well-defined plugin architecture at this point, but you'll see, for example, once I actually come down here, I have a high-level main, which calls an inner main, and the purpose of the high-level main is to catch errors and actually print out the anyhow context stack. Pretty much everywhere where I'm could throw errors, I'm adding context so that to make the so that if I ever catch an error at the top level, I can actually print out a useful chain of context, so you can trace errors easily. In the inner main, or this I'm calling CLI parse, I'm getting the input path. I'm not directly reading that yet because, for example, in the case of Zcash, I'm passing the path to it because it's actually calling out to the BDB dump or the DB dump utility. In this case, it's not directly reading in the binary. It's actually starting up a sub process to call that tool, and that's what's reading this in. Then it converts it from ZeWIF to envelope. And then it actually mounts that in the armature for I showed you for compression and encryption and so on. And then it basically says if it's going to compress at this point, it has a compress switch, then it actually compresses it at that point.
Question about that use of the BDB dump tools. So it's a specific version of BDB that Zcash has used. So that are you recompiling that version as part of the build process for this tool, or what are you doing there?
But no, basically, at least on the Mac, I use Brew to install the Berkeley DB tools. I looked for good crates for parsing Berkeley DB files, and
it is actually so the Zcash build process pins a specific hash of BDB and builds that. So, I mean, ideally, we would build exactly the same version that that Zcash does. I mean, I don't know whether that's within the scope of the grant, but
that's not for me to say, but I don't think it's really relevant because as long as DB dump can dump it, we can read it because then we dump it to a text stream and then we parse the text stream. So and we basically, as long as it's a set of key value pairs, then that's what we're parsing from at that point, and that's lossless.
Is the output of DB dump documented to be stable?
Yes, it's definitely stable. So basically you can actually go into our code here and you can actually look at the output of the DB dump and see how we're parsing it. As far as I can tell, it's absolutely stable. There's a header that includes certain kind of version specific information about the Berkeley DB file.
I did say documented to be stable, not
I did
to be stable, but
I heard you say that, and you might want to vet that a little bit more thoroughly, but from what I can tell, DB dump is designed to be parsable.
I see.
So it's not designed to be just, it's not like a lossy format like the envelope notation. It's designed to be parsable.
Cool.
For migration purposes.
It's just to be clear here. When this project is complete, there ought to be some security reviews and, including, what are the attack surfaces and things of that nature. That Zcash Foundation should fund, but as the creators of this, I don't think that we would be the parties doing the review. We would be the parties that would fix things or whatever. I mean, clearly, somebody could write some supply chain attack for Zcash wallets, such that they all convert and become the keys that they want them to be, or something silly like that. But that's kind of outside of the scope of at least this initial project.
I did have a question about key material, and this is more along the lines of what do you recommend? So in the Libra Zcash crates, at least, and we specifically use the secrecy crate for types that should be zeroized when they're dropped, so that they don't leave secret information on the stack. is there any like for things that are stored in clear text, um, a would you be willing to use like the secret vec and secret string types for the seed material? Admittedly, it is another dependency, but secrecy is a fairly light one.
Sure.
And then um, and then is there in the ZeWIF encryption, or at least I guess in the envelope encryption uh, process, uh, what uh, what is the ordinary path for that data? Um, like,
So yeah, some of the things our dependencies are using zeroize internally. We have not gone through our whole stack and made sure that we're using zeroize for everything or even selectively. And when in cases like this assertion here, where we have a clear text, essentially a private key, there's no reason why you can't easily convert this to store this as a CBOR binary string instead of a CBOR text string, and then it will just appear like this.
Well,
And then
to me, the case of an unencrypted either UR or whatever format it's in is really hard to do thorough sort of memory hygiene for, because it's being read in as a text file, and that process doesn't know where the boundaries of the secret information are. But if you're I would be more worried, and I would place a higher priority on that kind of memory hygiene when you start with an encrypted format. So
yeah,
when
so
you're
I guess
decrypting it, make sure that
probably this is the answer here is probably pretty simple, which is that if we use the secret string and secret vec types just for the in-memory representation in the ZeWIF crate, that's probably adequate, because everything else is going to be sort of outside the scope of that crate, and that would then be sufficient.
yeah, well, I mean,
There'll be clear
Yeah.
text in memory, but zeroized, so that you don't, a library using that crate then doesn't accidentally leave
Sure.
leave information on the
Well, I
stack.
think it's important to realize that,
Exactly.
for example, this is parsed out of a file where this was unencrypted. Okay, this was
Yeah,
not
and
decrypted from
that's fine. That's not a
and
problem.
so obviously you have to determine what you think your reasonable risk surface is and mitigate it. And that I think is probably outside the scope of the grant, but
I mean, to me, I would want everything to be compressed and encrypted by default, and that actually increases usability, because there's only one format and it's always expected to be that. Anyway,
So yeah, we
okay,
definitely.
so I have to drop.
Yeah. So Derry, I
Sure.
just also want to make sure you recognize that, we support multiple kinds of encryption, including Shamir. So it isn't
Right.
like just one form of a symmetric encryption. We support a bunch of different types, and that is really, an issue of when the other wallets want to do more with this, to decide, do they, what do they want to support? What are their needs?
I just want to make sure
Well,
there's two separate issues that we're
that
talking
we're
about here, though, 'cause
capable of
one
doing
is right. I mean, one is encryption at rest, which we have, nailed, and then there's, zeroizing everything in memory that might be sensitive to avoid in-memory attacks, and that's a completely separate and much thornier issue. I think
Right.
that's what we're grappling with here.
I mean,
Yeah,
certainly, I think we already do some of the zeroing now. I think that architecturally, it could be that certain things are tagged in some fashion, that we do special handling of values, et cetera. But that is not in the current library.
Less so in our, well, certainly not in ZeWIF. In our the rest of our stack, when it comes down to the primitive cryptography structures we're using, we're relying on fairly respectable implementations of those, and I'm sure those are using best practices internally, including zeroizing. However, when we're handling our own key material, for instance, if you look at the ZeWIF envelope here, there's actually a here's decrypt using symmetric key. Symmetric key itself is just an in-memory vector. It doesn't actually currently use zeroize or anything. And this is probably a candidate that we could go back and go through our stack and do that. It's something that at this point we haven't had a lot of call to do it. But I agree that at some point we'll need to do that. But knowing that you caught everything is the hard part, because it's really a matter of doing
and third party audits would also be useful for that. Okay, right. I have to drop. Cheers.
Thank you, Dorian.
I think like I said, I think that inside the ZeWIF crate, I know the crate relatively well now, because I've been using it for the past couple of weeks. So I think that there are only a few places where I might add some wrapper types.
Absolutely. Feel free to add a dependency and add those wrapper types where you feel they give you confidence. So with regard to that, if your changes, which they will, touch the actual ZeWIF format, for example, let's look at transaction here in ZeWIF. Obviously, the paradigm here is we have, from transaction for envelope and try from envelope for transaction, and these do the various kinds of parsing of the various structures and end up, handing off the actual structure. I also have, I'm using a fuzzing framework that I have called a trait called random instance. This is only compiled in when you're configuring for tests, and basically all these types have implement random instance or which basically includes possible optionality and stuff like that. So I'm testing various shapes of the structures, and to do that you have to do it repeatedly. I have a macro here called test envelope round trip, which, and there's another one for CBOR, for structures that only need to serialize to CBOR. This calls the test, basically tool of the same name here. Yeah. I just want to point out that there's this test envelope round trip here where we go through certain iterations. We actually re-encode it several times to make sure it's deterministic, to make sure, and I can go talk with you offline about that. And then we do the try from as well. And if we get any errors, we report them. So I'm doing that for pretty much at every level from the bottom to the top. So to make sure everything is stable and deterministic, no matter what the shape of the structures are. And that's pretty much it.